A PIN insulator is not the same thing as a surge arrestor. While both are used in electrical systems, they serve different purposes and have distinct characteristics. A PIN insulator is typically made of porcelain or glass. Its primary function is to insulate electrical conductors from a structure. It has a ribbed or textured surface, designed to increase the leakage distance and protect against voltage surges, but only up to a certain voltage level. A surge arrestor, on the other hand, is often made of ceramic or polymeric material. Its main purpose is to protect electrical equipment from high-energy voltage spikes. It works by diverting excess current to the ground. A key feature of a surge arrestor is its nonlinear resistance, which increases as the voltage increases. One major difference lies in their function. PIN insulators prevent current leakage under normal operating conditions, while surge arrestors divert excess current away from equipment during a surge event. This is a fundamental distinction in how they protect electrical systems. In terms of voltage handling, PIN insulators can handle voltage surges up to a specific level, whereas surge arrestors are designed to handle much higher energy spikes. This difference in capacity reflects their respective roles in an electrical system's protection scheme. Another difference can be found in leakage characteristics. PIN insulators leak small amounts of current under normal operation, while surge arrestors typically have no leakage. This is due to their different construction and operational principles. Regarding lifespan, PIN insulators generally have a longer lifespan than surge arrestors. This is because they are designed to withstand constant voltage stress, whereas surge arrestors are subjected to occasional high-energy surges that can degrade their performance over time. In summary, while both devices are designed to protect electrical systems, they serve different purposes. PIN insulators prevent current leakage and protect against moderate voltage surges, while surge arrestors protect against high-energy voltage spikes that can damage equipment. To further clarify their distinct roles, consider their applications in different parts of an electrical system. PIN insulators are commonly used to support and insulate overhead power lines from utility poles. They are essential for maintaining the integrity of the power grid under normal operating conditions. Surge arrestors, however, are often installed at substations, transformers, and other critical electrical equipment to protect them from lightning strikes and other transient voltage surges. Now let's delve deeper into the characteristics of PIN insulators. The ribbed or textured surface of a PIN insulator is crucial for increasing the leakage distance. This increased distance makes it more difficult for current to flow along the surface of the insulator even in wet or contaminated conditions. This helps to prevent flashover, which is the breakdown of the insulation and the flow of current along the surface of the insulator. The material used for PIN insulators, whether porcelain or glass, is chosen for its high dielectric strength, which is its ability to withstand high voltages without breaking down. Porcelain insulators are typically made from a mixture of clay, feldspar, and silica, which is fired at high temperatures to create a strong, durable material. Glass insulators are made from molten glass that is formed into the desired shape and then cooled. Now let's turn our attention to surge arrestors. The nonlinear resistance of a surge arrestor is typically achieved using metal oxide varistors, MOVs. These devices have a high resistance at normal operating voltages, but their resistance decreases dramatically when the voltage exceeds a certain threshold. This allows the surge arrestor to divert excess current to ground quickly and efficiently, protecting the connected equipment. The surge arrestor's ability to handle high energy spikes is measured in terms of its surge current rating, which is the maximum amount of current that it can safely divert to ground without being damaged. Surge arrestors are available with different surge current ratings to suit different applications. It's important to select a surge arrestor with a surge current rating that is appropriate for the expected level of surge activity in the area. Furthermore, it's crucial to understand the limitations of each device. PIN insulators, while effective at preventing current leakage and protecting against moderate voltage surges, are not designed to withstand high energy spikes. Exposing a PIN insulator to a voltage surge that exceeds its capacity can damage the insulator and potentially lead to a power outage. Surge arresters, while highly effective at protecting against high energy voltage spikes, are not designed to prevent current leakage under normal operating conditions. Using a surge arrestor in place of a PIN insulator would not provide the necessary insulation to prevent current leakage and could create a safety hazard. Therefore, selecting the appropriate device for a given application requires careful consideration of the specific protection needs. If the primary concern is to prevent current leakage and protect against moderate voltage surges, then a PIN insulator is the appropriate choice. If the primary concern is to protect against high energy voltage spikes, then a surge arrestor is the appropriate choice. In some cases, both PIN insulators and surge arresters may be used in conjunction to provide comprehensive protection for an electrical system. For example, a PIN insulator may be used to insulate a power line from a utility pole, while a surge arrestor may be installed at a nearby substation to protect the substation equipment from lightning strikes. Understanding the key differences between these two devices is essential for ensuring the safe and reliable operation of electrical systems. By selecting the appropriate device for each application and understanding its limitations, you can effectively protect electrical equipment from damage and prevent power outages. Finally, consider that the installation and maintenance of both PIN insulators and surge arresters should be performed by qualified electrical professionals. Improper installation or maintenance can compromise the effectiveness of these devices and create a safety hazard. Regular inspections should be conducted to identify any signs of damage or deterioration, and any necessary repairs or replacements should be made promptly. In conclusion, PIN insulators and surge arresters are distinct devices with different functions, voltage handling capabilities, leakage characteristics, and lifespans. They serve different purposes in electrical systems and should be selected based on the specific protection needs of the application. Proper installation and maintenance are essential for ensuring their effectiveness and preventing electrical hazards. The selection depends on the level of voltage the device is expected to handle, and if there is no voltage, then no current is expected to leak. It is important to select the right device for the right application. The device can be used in conjunction together as well, depending on the scenario and the electrical equipment in use.